Hey everyone, I just wanted to give a quick update. I know I haven't uploaded that much on this channel, but I have reached specialist on code forces. If you see my rating graph, it's like a pretty good progression, I think. But as you can tell from my rating graph, when I was sort of basically spamming all those videos, I was, kind of still a newbie. Um, so. Like nowadays, I think it's hard to just I was or back in the day, my motivation of making these such videos was anything I found like somewhat interesting or like anything I was learning, I was just put that on YouTube just for like, my future self to reference back on it, which is why I also added a lot of implementation in C++. So again, if me in the future, I can look back on it if in case I ever need to reference anything. But I think my motivation's changed at this point. Um, Looking back at some of my old videos, I could see that I wasn't really good at explaining that well. Um, it was mostly me iterating some of the editorial stuff, which was kind of worse than the actual editorial itself, I admit sometimes. Um, And yeah, I think I'm going to change my style of content, starting off with just omitting the implementation. I'll have, um, I'll probably link some of my submissions um, in the description or something if you really care about implementation or, future me really wants to look at it. But, I've gotten good enough at C++ to like not have it in the video. And I think it distracts from the point of the video and it makes it too long. So yeah. This video is just an update. Probably be start to post again. Um, and yeah, for this video, just starting to get back into it, I'm going to go over some of my highlights from this blank or this whole time of not posting. Starting off with um the educational code forces round 151. Okay, and I've picked two problems, problem B and problem D. Um, that's, okay, you'll see why I chose them once I start. So here's problem B. Feel free to pause the video and read the question before I begin. And so this problem can actually be solved using an idea from one of the previous videos I've posted. And so I think that was actually helpful for me to have learned that idea. But essentially, it's this. If you can think about the first example, right? Going from A to B, you have to go up two and then left two. So no matter how you do it, you can go up, left. They'll just give you, as long as you go up two and go left two, this will give you the shortest path from A to B. And so from A to C, same concept, except this time it's up three, right three. And so you might have noticed that, again, any way you go up two and left two, right? You can go left up or left up, or left, up. No matter what sequence you do them in, you will get a shortest path. Same with C. So the answer lies in the shared paths. So you can see that they both have to go up at least two. So if you both have to go up at least two, might as well walk those two together, right? And so, but in this case, right, one goes left and one goes right, then you can't really share any paths because you're going in opposite directions. So essentially, the answer to this is just if you're going in the same direction, you can add the minimum of let's say D, it means distance, distance to B, distance to C, and of course this is X or, and then this applies to X or Y. So you have to check both X and Y because this is a two-dimensional grid. And of course, or let's make this not in the same one. And then you add in the minimum of distance to B, Y, distance to C of Y. And of course, you both start at the same one and they count that in the answer, so you have to add 1. And this is only in the same direction. The opposite direction would basically give you 0, right? They don't share anything. So this is pretty short and sweet. Again, I got the idea from the robot paths, which is pretty cool to me because I don't know, that helped me get this question pretty quickly. And yeah, as for implementation, take a look here. Just a bunch of math, reading, mainly just reading in, figuring out if they're in the same direction. You just take the minimum of their absolute values. Okay, cool. Now we move on to D. So again, feel free to take a minute, pause, and read this question. Maybe try it out yourself if you want. And let's open a new one. Okay. So why I wanted to showcase D was because D was, or I actually solved D during the contest. So Div 2D, I usually can't. I struggle with C, and solving D is kind of surprising in this case. And it's the highest problem I've solved so far. And yeah, I would just like to go through my thought process. And I think this was achievable for anyone as long as the implementation itself is not that hard. It doesn't need any like fancy techniques. So as with any question or problem, you have to go look at the extreme cases. And so let's start from the extreme cases and see what we can determine. So let's say our first extreme case is that let's say the x-axis is the number of battles and the y-axis is the rating. So this case, so let's think about here, right? The rating only increases. Well, at this point, you don't want to limit, right? You don't want to limit it, or essentially what you can do is to set the limit at the very end. Or essentially you can consider the limit infinity. Which I think this case is pretty self-explanatory, and so along with the opposite case. So here it's just nothing but going down, right? And so let's label this x. This is minus y. This is y. And then it just goes nothing but down. Well, in this case, you would prefer to just start in the beginning, right? So in this case, the answer would just be 0. Just keep it at 0. These cases might be relatively trivial. What about the cases? Let's expand this a little bit. So what if I were the rating graph, give you a rating graph that look like this? It's not strictly decreasing, but there's a positive increase, and then before it goes back down again. And then we can say, hey, guess what? Is there anything in the second case of just staying in the negatives? Is there something we can do to make it better than 0, like better than choosing 0? And the best rating we can achieve is here, which is less than 0. So in this case, like even with the positive spike, we're still less than 0. So we have to, like, the answer to this is still 0. Let's look at the corresponding positive case, right? So let's say you're going up, and then you spike down a bit, and then you go back up. So in this case, is it still that you want to, put the very top as the rating? Well, let's think about it. If we want to, or if we don't want this drop right here, we can actually prevent it, right? We can essentially turn this drop into a smooth, like basically instead of going down, you can do this. And since we're setting something where it won't change, we can make it so that it doesn't change and then have it go back up again. So the length of this, or this, is actually essentially equal to this, right? And so because we're not going down, we actually end up at a higher max in the end. And so we want, like from this case, you can see that we want to give the limit or set k to be here before it decreases. Now, I would like to give one last case before I go ahead and like generalize to the solution. Here, let's say I go down, it goes up, and then back down. As you can see, it's similar to this example here, right? Similar to this example here, that we want to make it stop right here. And so we want to set k there so that instead of it, going down, we would essentially replace this downward line with just a flat. So it would look like something like this, and then just a flat line afterwards. And again, so this would stay in the positives. And by now, you might have already noticed a pattern here. And the pattern that I've noticed is that we essentially want to set the start point before it starts decreasing, or the biggest decrease, I would say, because it did start decreasing a little bit here, and then it went for the biggest decrease here. Same here, except setting the start point here would be less than 0, so we just say it's 0. And then same here, there's only one decrease, so let's stop it before here. And so if you think about, let's say there's a small decrease here, it'd be more worth it to set the stop point here because it has a bigger decrease. So we set k equal to the point before the biggest decrease. So how do we find the biggest decrease? Well, we would use the idea from the maximum subarray. So with maximum subarray, you find which is essentially a problem of finding the biggest sum of a subarray of the whole entire array. And we can instead flip it to find the biggest decrease. So maximum or minimum subarray sum. And once we have that, it becomes relatively easy, except one thing that we need to do is we need to know where it starts, right? So we can modify the minimum subarray algorithm to also give where it starts to find out k. So for example, if we have something like this, like I showed before, let's do a little bump here and then a large bump here, right? And so we can put the start point like this index, let's call it I, for example, and then k would just be the sum of the array from 0 to I. So it'd just be sum of the we'll call it R as the rating from 0 all the way to I. And there's our answer. Of course, if I is 0, that would mean the array is just always going down. So we know the answer is just 0, k equals 0, like one of the cases I showed before. All right. So that's about it. Again, implementation. Let's give you can take a look here. It's not the prettiest, I know, but essentially it's the same idea. You can look at the LeetCode tutorial, or there's a bunch of solutions out there for max subarray sum. So you can basically reverse that into minimum subarray sum, and then just add something to keep track of the start point, and then essentially get your answer from there. That's all from me. Thanks for watching.